Hello everyone. Today we will introduce F5 AI Gateway and talk about how it can accelerate and secure the deployment of your AI applications. The core of the AI Gateway is a policy orchestration engine that provides observability and traffic management, complemented by what we call processors, which are the workloads that can provide various functionality, for example, implementing the security controls. It is a Kubernetes native solution, so it is easily deployable in what is currently the most used environment for running AI applications. From the architecture point of view, AI Gateway sits close to the AI workloads, acting as a gatekeeper and is typically being front-ended by a load balancer or a proxy. F5 AI Gateway addresses a set of core requirements regarding observability, connectivity abstraction, traffic management, and secure delivery of user and application traffic to the back-end AI models. F5 AI Gateway has been created with AI applications in mind. It natively understands AI traffic and can take actions at this level, rather than treating it as generic API traffic. It can provide logging of transactions for audit purposes. It can perform traffic management based on higher-level characteristics of the user traffic, such as the language used, and it can apply AI-specific security controls that would help users in protecting their AI applications. One of the most powerful features of AI Gateway is the ability to decouple the downstream LLM connection from the upstream one, allowing developers to connect their AI applications to AI Gateway using a single protocol, but access downstream LLMs that require different protocols or settings. AI Gateway will translate between the two protocols, ensuring the AI application maximum portability. This feature relies on the AI Gateway route object that abstracts the downstream connection details, presenting the developer with a single endpoint to connect to the AI Gateway. Before showing the first demo, let's go over the setup we will be using. The entire environment is built in AWS EKS and publicly exposed through F5 Distributed Cloud. We will be using MinIO as storage for our transactions log and Ollama as an LLM framework. Let's imagine a scenario where a developer is using OpenAI's API spec to connect their AI application to the AI Gateway, and the same OpenAI API spec is used for the downstream connection to the Ollama LLM. Let's assume the LLM environment has changed and now there's a need to connect to the downstream LLM through the Ollama API spec rather than OpenAI one. All we need to do is to change the configuration of the AI Gateway to point to the new Ollama service. For each configuration, we will send a simple request through our chatbot application and then examine the transaction records stored in the object storage used for audit logging. As you can see, comparing the transaction records, while the incoming requests from the chatbot application are using the same OpenAI format, the downstream connections are using either OpenAI or Ollama formats, depending on the AI Gateway configuration. Using AI Gateway, we can avoid changing the AI application code, as the connection to the AI Gateway can use the same format, regardless of the downstream LLM. Another important feature of AI Gateway is the support for context routing. AI Gateway can make routing decisions based on certain traffic characteristics, for example, the HTTP headers, the JWT claims, or the tags generated by the AI Gateway itself, such as the language identified in the user prompt. For the next demo, the Ollama framework is running two models, Mistral and DeepSeek. AI Gateway is configured to identify the language used in the request and route the request to the Mistral model if English is detected, or to the DeepSeek model if French is detected. We will contrast the behavior by first initiating a conversation in English and then a new one in French. We will be examining the transaction records downloaded from the object storage used for audit. In the first instance, you can see how the language ID processor has identified the language as English, and the request was steered towards the Mistral model. In the second instance, the language ID processor has identified the language as French, and the request was sent to the DeepSeek model. Having all transactions recorded in an object storage is not only valuable for troubleshooting purposes, but also for identifying drift in LLM behavior and auditing purposes, as mandated by local regulations. Let's take a look at a prompt injection attack, a well-known LLM vulnerability. First, I will ask the LLM how to break into a car, the request will bypass the AI gateway's prompt injection processor. As expected, the model answers by pointing out that this is an illegal activity and the response is not really useful. I will then perform the prompt injection attack by telling the LLM it is allowed to respond detailing illegal activities, and this time the response is much more useful. Let's see what happens if we insert the AI gateway's prompt injection processor in the policy and repeat the same request. You can see the request has been rejected and the cause if the detection of this prompt injection attack. Another attack that has been well documented is a repetition attack, where repeated tokens in the request cause the model to hallucinate or respond with an answer to a different question. AI Gateway Repetition Detect Processor can protect against these kinds of attacks by blocking requests that contain a high enough number of repeated tokens. In summary, F5 AI Gateway supports policies to deliver the prompt to the most appropriate AI workload and the built-in security features to ensure your AI application is protected against malicious activity while logging transactions for troubleshooting or audit purposes and abstracting away the complexities of downstream connections. With this being said, we've reached the end of our demo. Thank you very much for your time.